Welcome guys, welcome to my channel. I hope you all are fine and doing great. So today we are going to discuss this lead GFG problem, leaves to DDL. So in this problem, this is the problem of the day of GFG of 21st January. So what we have to do in this problem, we are given with a binary tree, and what we have to do, we have to put all the leaf nodes in a doubly linked list like this and modify our tree so that all the leaf nodes will represent null, so that our tree will look like this. Okay, so and in this case, as you can see here, 4 5 and our 3 is the doubly linked list, will form a doubly linked list, and tree will look like this. Okay, and our doubly linked list will start from 4 and end with our rightest node. So it will start from the leftest node and go to rightest node. So how can we do it? I am showing you the code and explain it. Like here we are given this convert to DDL function, in which we have to return node star. So you can see here we have to return in convert to DDL, we have to return the head of the doubly linked list. So you can see here is node, so we will store our doubly linked list in same nodes as in which our tree nodes are stored. So we are given the root node of our binary tree. So I take two variable s and t. You can see in above, I take and I initialize them both with null in starting and call a function solve and then return s. Now this s is the head of my, I am writing here, head of DLL is this s is my head of my doubly linked list, and t will represent the current node of my DDL doubly linked DLL, sorry, of my doubly linked list. Like assume if I have this 0 is representing a node of my doubly linked list, then this is s and my linked list is like this, and then this is my t will represent this node and my s will represent this node. Okay, so now what is my solve function? If my r is equal to null, then I just return null. Else if I found a leaf node, I found a leaf node, so that my r dot left is equal to null. You can see I use node operator here, and similarly my r dot right is equal to null, means I am the current node is a leaf node. So what I do, I will take a new node n, initialize it with my root dot data, and if my s is equal to null, means this is my first node, then I just initialize my s and t with n, because my starting node is just wait a minute. As you can see, in starting, when I have only one node, then this is my starting node and this is my current node as well. So s comma t will represent the same node as at this time. Okay, so now else if we have something in our s, then what we can do, like here it is reconnecting, wait a minute, like if we are iterate with this particular node, this is a leaf node, as you can see its left is equal to null as well as right is equal to null, and we are iterate with this node, then we make a new node. You can see my n, I will form a new n, and suppose it has a value 1. Okay, then I will form a new node of value 1 whose left is equal to null, whose right is equal to null, and okay, and take this is my s, s point to this point to this, and my t point to this. Okay, so I can say that this is my starting node, this is my current node, so I have to add this n after this. So what I will do, what I am doing, I put the address of t in the left of my n. in this left I put the address of this, so that this will now point to this, and this will cut down this, and this is a double linked list. So this both represent locate the address of each other. Okay, in next step what I do, in the right of t I put the address of n. Okay, so in the right of t point to this, so its left point to this, its right point to null at current moment. But now what I do, I modify its null so that it will point to this, it will point to this. Then what I do, in my t I will I point my n, in my t I point my n, so that now my t will not point this, my t will point this. So how is our updated linked list look like? As you can see, as it is a doubly linked list, so we have two node and this node. As you can see, this node point to this, you can see this node point to this, the left of this node point to this, the left of this node point to this, so the left of this node point to this, and right of this node point to null. As you can see, point to null, so it will point to null now. And my t is point to this node, my t is point to this node, so this is my n node, that is x, that is add, so my t will now point to this node. So by this type I will update my linked list at each step, and I will return null ptr. So here my solve function will return null from here. Similarly for this, I will make a new node value is equal to this, then just do the same operation and add the this node in front of this. Okay, and return null from it. So how will it look like after updating this? This will point to null, this will point to null, or we can say it will look like we can say this will look like a single node. Okay, so I have updated my, so what I done, this is given to us a binary tree, and r is this. Okay, and s is equal to point to null t sorry t point to null. And after updating what I got, I am changing the color. My r will point a single node, my s is point to two node because there is two leaf node. Okay, s, this will point to this, and in my doubly linked list the left of this will not point to my s. Okay, and my t is point to my this node. Okay, so this is how we update our linked list. I will remove both of the leaves from my tree and add it in a my doubly linked list. Okay, and how I iterate, I do solve r dot left and put what it written in the left part of my root, and similarly for right. And after doing, I will return this. Like suppose if there is some more tree to it, this tree part of, so after it we will return sorry this. Now this will contain null, these both are same, and the above tree is completely same because we have to just remove the leaf nodes, and we remove leaf node, so our above tree will be same. Sorry, so I hope you understand it. I am just dry run it, checking it. What error? Oh, okay, this error. You can see as I tried it to show you. As you can see, so you can see okay, so you can see all the test cases, all the 400 test cases pass out. Time is also very less, so correct submission 2. So I hope you guys like it, and if you like it, then please subscribe the channel for more coding amazing content. And you can check out my channel for more solution of daily lead code problem and daily GFG problem solution. So thank you for watching this, guys. Thanks a lot.